Hello students, good day and welcome back to this channel. In today's video, we are going to look at the topic modular arithmetic. We are going to learn how to calculate the value of numbers for a given modulo. Now let's start today's lesson by defining what modular arithmetic means. Modular arithmetic, sometimes called modulo arithmetic or clock arithmetic, is a system of arithmetic for integers where numbers wrap around after they reach a certain value called the modulos. So we are saying that modulo arithmetic is a system of arithmetic for integers where numbers wrap around after they reach a certain value called the modulos. Now the best way to introduce modulo arithmetic is to consider the phase of a clock. In this video, we are going to consider the 12-hour clock. Now you realize that the 12-hour clock goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So that is for the 12-hour clock. Now let's consider two cases. 1. Assuming it is 8 o'clock now. What will be the time in 5 hours? So in 5 hours time, basically we are going to add 5 to 8. So we have 8 plus 5, which is equal to 13. So we say that it is 13 o'clock. But instead, the clock does not display 13 o'clock. It displays 1 o'clock. Now let's consider the second case. Assuming it is 10 o'clock now. What will be the time in 4 hours? So in 4 hours, we are going to add 4 to 10, and then we have 14. So we say that the time is 14 o'clock. However, the clock displays 2 o'clock. Now what does this mean? What this primarily means is that the 12-hour clock is modeled to operate in modulo 12. So for this case, the numbers wrap around after reaching 12. So instead of moving on to 13, 14, 15, 16, and so on and so forth, they rather wrap around and start again from 1, 2, 3 through to 12. And if the number is still greater than 12, then it's going to wrap around and then begin from 1 again. So for instance, for the first case, we had 13 o'clock. So on reaching 12, the clock is going to wrap around and then begin from 1. So instead of 13, the clock is going to read 1 o'clock. For the second case, we had 14 o'clock. So on reaching 12, the clock is going to wrap around and then begin from 1. So this is 13 and then 14. So the clock is going to display 2 o'clock. That is why we have 1 o'clock instead of 13 o'clock and then 2 o'clock instead of 14 o'clock. Now before we start solving some questions, let's consider this very important thing. Given a particular modulo, say modulo 2, which is written as mod 2. Now the 2 suggests that we have only two numbers in modulo 2. 0 and then a number 1 less than 2. So that is 1. So in modulo 2, we have only two numbers, that is 0 and then 1. So always we start from 0 and then we end at a number 1 less than the modulo. Now let's consider modulo 5. For modulo 5, we are going to have 5 numbers, starting from 0 and then ending at a number 1 less than 5. So we have 0, 1, 2, 3, and then 4. For modulo 7, we are going to have 7 numbers in this modulo. So that is 0, 1, 2, 3, 4, 5, and then 6. So if a number is greater than the modulo, then on reaching the last value, it is going to wrap around and then start from 0. Then upon reaching the last number, if the number is still greater than the last number, then it's going to wrap around again and then continue the cycle until we finally arrive at a number less than the modulo. So without wasting much time, let's solve these questions. Okay, so now we are going to simplify the following. We have 8 questions in all and we are going to solve all of them. Question 1, 24 modulo 5. Now if you have 24 modulo 5, in the previous section we said that for modulo 5 it means that it consists of 5 numbers. So these numbers are 0, 1, 2, 3, and then 4. Now if the number is greater or equal to 5, then upon reaching 4, it is going to wrap around and then start again from 0. So this cycle is going to repeat over and over until we get a value that is less than 5. Here we have 24. Now the best way to reduce this number is to divide 24 by 5. Now 24 divided by 5 gives us 4, remainder 4. 5 times 4 is 20, and then 24 minus 20 gives us 4. Now we are interested in the remainder, so we can reduce 24 mod 5 to 4, which is the remainder mod 5. So this is how to simplify 24 mod 5. Now let's solve the second one. So 57 divided by 7. 7 times 7 gives 49. So 7 times 8 will give us 56. So this is going to be 8 remainder. Now 57 minus 56 is 1. So we have 8 remainder 1 when we divide 57 by 7. Now since we are interested in the remainder, then we write 1 mod 7. Now let's solve the third one. We have 75 divided by 9. 9 times 6 is 54, 9 times 7 63, 9 times 8 72. So we have 8 here because 8 times 9 is 72. Remember 75 minus 72 is 3. So this becomes 3 mod 9. For question 4, we have a negative value. So in simplifying modulo of a negative number, we are not just going to divide by the value of the modulo. However, we are going to add the value of the modulo, which is 4, to negative 23 until we get a positive value less than 4. So that is what we are going to do. We are going to add 4 to negative 23 severally until we get a positive value less than 4. So we have negative 23 plus 4. That will be equal to negative 19 plus 4. That will be equal to negative 15 plus 4. Negative 11 plus 4. Negative 7 plus 4. Negative 3 plus 4. That will be equal to 1. So we are going to have 1 mod 4. Let's solve question 5. We have 4 plus 5 mod 3. Now in simplifying a question like this, we are going to add 4 and then 5. So 4 plus 5 is 9. So this becomes 9 modulo 3. Next, we are going to divide 9 by 3. So 9 divided by 3 gives us 3, remainder 0. So this will be equal to 0 modulo 3. So this basically means that when you divide 9 by 3, you have the remainder to be 0. Let's solve question 6. Negative 4 plus 9 plus 23 modulo 8. So we are going to add up all these values. Negative 4 plus 9 gives 5. 5 plus 23 is 28. So this can be simplified as 28 modulo 8. Now the reason why we are reducing this value is that 28 is greater than 8. So we need to get a value that is less than 8. That is why we are going to reduce this value. Now we are going to divide 28 by 8. 8 times 3 is 24. So we have 3. Remainder 28 minus 24 is 4. So remainder 4. So it means that 28 modulo 8 can be simplified as 4 modulo 8. Now at this point, you can choose to pause the video and work out the last two questions. After that, you can play the video to see if you got the same answer as what I had. We have 4 times 8 modulo 5. Now for this case, we are going to treat this like how we treated question 6 and then question 5. So we are going to multiply 4 by 8 and then we have 32. So this becomes 32 mod 5. To simplify this, we are going to divide 32 by 5. 5 times 6 gives 30. So we have 6 and then 32 minus 30, we have 2. So remainder 2. Now this is equal to 2 mod 5. Now to the last question, let's multiply 23 by 4. So 23 by 4 gives 92. So we have 92 mod 10. So dividing 92 by 10, that's going to give us 10 times 9 is 90. So we have 9. Remainder 92 minus 90 gives us 2. So we have remainder 2. So this is going to be 2 mod 10. So basically, this is how to use the idea of remainders to determine the modulus of a number. Now you can solve a lot of examples on your own as well. That's it for today's video. Thanks for watching and see you in my next video.